Hello, this is Mr. Flatness, and in today's lesson we're going to be estimating fraction products. To start out our lesson, we're going to again look and focus on some vocabulary. We're going to again talk about this concept of compatible numbers. Again, those are numbers that are easy to multiply or divide, and we've talked about how those are the same thing as your basic fact numbers. A bar diagram is basically a picture, and it represents the part of the numbers that we're working with. So I have an example to show you here. It says find 2/3 of 15. So 15 is my whole number. So what I'm going to do is create a box here. This big huge rectangle that I am drawing around, that big rectangle is going to represent 15. 15 of anything. So from that point, then I'm going to look at the denominator. Now what I want to do to that 15 is I want to split it into 3 equal parts. So notice I have this whole rectangle split into 3 equal parts. And then my numerator here tells me how many of those pieces I want to color in. Notice that 2 of the 3 are colored in a brownish color, light brownish color. So the final piece is to think and look about this. If I take 15 and divide it into 3 equal parts, each part then would be worth 5, because 5 plus 5 plus 5 is 15. Or the other way to think about it is 5 times 3 is 15. So then if I wanted to find out what 2/3 of that was, I would simply add up the 2 bars that were shaded. 5 plus 5 then would give me 10. So 2/3 of 15 would be 10. And that's a way to use pictures in order to show how to multiply those two fractions out. So as I said at the beginning of this lesson, we're going to be working with estimating products. Sometimes we have numbers that don't quite work out as easily as the slide that we had before this one. Notice in my first example I have 1/4 times 19. And the second problem I have 1/5 times 28. And 1/9 times 68 is my last one. And in the previous slide, we had 2/3 of 15. And the nice thing about that was 3 and 15 worked out really well. I can take 15 and divide it into 3 equal parts quite easy and have nothing left over. So with these problems, notice I can't take 19 and divide it into 4 equal parts and get 4 equal wholes, nor can I take 28 and divide it into 5 equal pieces, or 68 and divide it into 9 equal pieces, because there are no basic facts. There's nothing times 4 that's a whole number that would give me to 19. So here's where my estimating comes into play. I want to use compatible numbers, 4 and 19. They are not compatible. So I want to change one of these or both of these so that they are. So I have 4 and 19, and when I look at this 4, I know that 4 times 5 is 20. So what I can do is, instead of working with this 19, I can think about it in terms of 20. I can round it up just a little bit, and this is what estimation is all about, trying to find compatible numbers. Well, I know now that 4 and 20 work quite well together. So if this whole long bar here represents the fraction 20, I can take it and split it up into 4 equal pieces, knowing then that each piece would have to be 5, because 20 divided by 4 is 5. Okay, and then I want to know how, so that's what I did. First I took my 20 and divided it into 4 equal pieces, and now I want to know how much one of those is. Well, one of those pieces then would be worth 5. So 1/4 of 20, or 1/4 times 20, is going to equal about 5, and that's going to be my estimation. So now I can use the bar diagrams like what I've shown you, or you can simply use the numeric model like this. It doesn't matter. In your homework you'll be working more with things like this, but if you need to draw the bar diagrams to help you out, that is fine too. Let's try the next one. Problem number 2, 1/5 of 28. Again, looking at these two numbers, 5 and 28, they are not compatible numbers. So I want to change either one or both so that they are compatible. And so looking at the number 5 here, I know that my multiples of 5, I can get a number that's close to 28 if I choose 25. So instead of 28, I'm going to think about 25. And it's okay to round down, okay? I could also think about 30. So now I have a choice. Which one should I choose, 25 or 30? Which one is 28 closer to? Well, when you look at it, 28 is closer to 30. So instead of using 25, I'm going to use 30. So this big long bar here that I have represents the fraction 30. And then I can take this 30 and divide it into 5 equal pieces. Okay, and so now that I have that 30 split into 5 equal pieces, I know that I'm going to have 6 in each box, because 6 times 5 is 30. And then again, the final piece to this is so I've taken this 30 and I've split it into 5 equal pieces, and I want to know how much is going to be in one of those slots. So 1/5 of 30 would give me 6. The numeric model would simply be written like this. What is 1/5 of 30? Well, that'd be 1/5 times 30. And again, I could use canceling to come up with 6. Either way. So again, you can use bar diagrams to kind of help you think about it, or the numeric model. Remember that the numeric model is going to be quicker and easier and involve less space in your homework. Let's try one more. And in fact, I'm going to adjust it a little bit. And let's go 2/9 to show you something a little bit different. I want to know what is 2/9 of 68, or times 68. So again, I'm going to look at the denominator and this whole number. They are not compatible. I want to think about my multiples of 9. I know that 9 times 7 would give me 63. So I don't want to think of 68. I could think 9 times 7 is 63, or 9 times 8 is 72. So in looking at both of these numbers, 63 and 72, which one would be closer to 78? Well, 63 is 5 away from 68, but 72 is only 4 away. So then I'm going to choose 72. And so now I'm going to just take this rectangle and think about it. That big rectangle is worth 72. And I want to split them into 9 equal pieces. And I'm going to take that box and split it up into 9 equal pieces. So I'll take a look at that by first kind of splitting them up into thirds, and then taking the thirds and splitting them up into thirds. So now I have 9 equal boxes, and so I know again that 72 divided by 9 would be 8, so then there's going to be 8 in every box. And now this time, I don't want to know how much is going to be in one box. This time I'm looking at, I want to find out 2/9. So I'm going to find out how many would take up 2 boxes. So now I take a look at, well, here's 2 of the boxes. And those 2 8s together, if you add them together, you get 16. So 2/9 of 72 is 16. So that's a good estimation for what 2/9 of 68 is. So again, the numeric model, if I wanted to estimate, I would simply do 2/9 times 72, or 72 over 1, and I would cancel, divide them both by 9. 9 divided by 9 is 1, 72 divided by 9 is 8, and I would get 16 over 1, which is 16. Again, these answers that I've created are all estimations, each one of these, because I don't want to know the exact answer of all these. I want to know the estimate, so I changed them into compatible numbers, and then I was able to use either pictures or numbers to come up with answers that are reasonable. Another way we can estimate is by rounding our fractions. And so what I want to talk about is proper fractions, again where the numerator is smaller than the denominator. We have 3 different ways. It can be rounded to 3 different numbers. I can either round a fraction to 0, a half, or a whole, because that's where all proper fractions are between 0 and 1. So when we round it, we want to compare the numerator to the denominator. So, and if your numerator and the denominator are far apart, then the value of that fraction will round to 0. So, thinking of an example here of 2/10. If I were to have the fraction 2/10, notice that the numerator and denominator, 2 and 10, are quite a ways away from one another. Because of that, I know then that 2/10 would be somewhere around in here on my number line, which is close to 0. If the numerator and denominator are about half, okay, of each other, then that fraction will round to half. So keeping with the same denominator of 10, let's say I have a fraction like 6/10. Notice here, 6 and 10 are roughly, 6 is roughly half of 10, just a little bit more. So therefore, on this number line, 6/10 would go somewhere in here, which again is close to a half. So 6/10 would be about half. Again, 2/10 would be about 0. And finally, if the numerator and denominator are very close in value, then that fraction will round to 1. For example, if I had the fraction 9/10, notice how 9 and 10 are very close together, which means that that particular fraction would round to 10, and 9/10 would be somewhere here on the number line. So that would be about 1 when it rounds. So those are your 3 different ways on how to round fractions. Again, fractions are going to round to 0, a half, or a whole. And you just have to compare the numerator to the denominator. So let's take a look at some examples. In the first example, I have 1/8. So I'm going to compare and look at 1 and 8. Quite a ways away from one another when you think about it. I also can think about the fact that 4 out of 8 is exactly half, and 1 out of 8 is less than 4 out of 8. So therefore this fraction would round to 0. And these squiggly lines I'm drawing that kind of look like the equal sign is a sign that says about. So 1/8 would round to 0. 7/8, if you look at that, these two numbers are very close together. So therefore 7/8 is going to round to 1. And the final fraction that I have is 7/15. So when I look at the denominator of 15 and look at 7, I know that 7 is right around half of 15. In fact, 7.5 would be exactly half of 15. So then 7/15 is going to be your rounding to 1/2. So in the following 3 examples, we're going to be rounding the fractions this time to come up with our estimate. So in looking at our first example, 4/5 times 1/6. 4/5 is a fraction where the numerator and denominator are fairly close. So that's going to round to 1. 1/6 is a fraction very close to 0. So I could round that to 0. So my answer could be 0. And that would be an acceptable answer. However, we also know that 1 times anything is itself. So like anything, if I round 2 numbers, I can be kind of close. But if I only round 1 number and keep the other number exactly the same as what it was, I can even be closer yet. So an even closer estimate would just be 1 times 1/6, which is 1/6. So both answers would be acceptable. The 1/6 would be just a little bit closer, and that's the one I would probably use. So 4/5 times 1/6 is roughly 1/6. But you could also use 0. In the next example, we have 5/8 times 3/4. So 5/8 is a fraction that is close to 1/2. And 3/4 is a fraction that is close to 1. 3 and 4 are very close together. So 1/2 times 1 is going to give us, and that would be equal to 1. So then an estimate for this particular problem would be 1. In my final example, you'll notice I have a mixed number times another mixed number. So again, I'll keep these. Looking at 7 and 1/5, that is 7 plus a fifth. So when I look at the fraction 1/5, those two numbers are fairly far away. I know that 2.5 is exactly half of 5. So I know that 1 is less than that. So I'm just going to round 1/5 down to 0. So 7 plus 0 would give me 7. I'm going to multiply that times an estimate that's close to 4 2/3. 2/3 would be a number that is very close to 1. So 4 plus another 1 would be 5. And I know that 7 times 5 is 35. Therefore, I know that 7 1/5 times 4 2/3 is going to be right around 35. Here's a final problem that is an application problem. So we're going to apply our knowledge of estimating fractions to a problem-solving situation like this. We have a drawing here. It's a drawing of a rectangle, and according to the word problem here, it's basically a rectangular room. And what we want to do is, if we wanted to carpet this room on this floor, we need to know how much carpet we need to buy. So I'm going to estimate to see how much carpet we would need for the room. So to find the carpet and how much carpet I would need, I would need to find the area. So the first thing we need to know about area is equal to length times width when we're working with rectangles. So basically I just need to multiply 9 1/9 times 5 1/6, or sorry, 5 5/6. So looking at this, I'm just going to simply do some rounding and come up with a quick answer. 9 1/9 is going to round down to 9. So area is equal to length times width. So then my area would equal, my length is going to be about 9, and my width here, 5 5/6, I'm going to round that up to 6, because 5/6 is close to 1, so 5 plus 1 more is 6. So that would be 6. So then here, 9 times 6 is about 54. So a very good estimate for how much carpet I would need would be 54 yards, and then we would use the appropriate area label, yards squared. And that would be more than enough carpet I would need, so I wouldn't have to be worrying about being short on carpet. I'd have a little bit extra. So that's why this becomes a good estimate for the problem that we're dealing with. So that concludes the lesson on estimating fractions. Remember, there's two ways you can estimate fractions. We can either use compatible numbers and multiply for a good estimate, or we can round the fractions and then multiply to come up with a good estimate.